We're looking at example 2. We have the graph of f given below here. And we want to sketch a reasonable graph for f prime on the right. So first, we can see that we have this function right here decreasing. And so that means that its derivative is going to be negative. I also can see that I have some lower values, smaller slopes, and some higher values. So it's going to go from low values to high values. Remember that the domain of the function cannot be any larger than the domain of the graph, or the domain of the derivative can't be any larger than the domain of the original function. So if the domain of the original function excludes -2, then the domain of the derivative will also exclude -2. See, pretty. All right, so first thing we're going to do is just make our vertical asymptote right there at x equals -2, because that's also excluded from the domain of the derivative. So I'm decreasing, so I have negative values, so they need to be below the x-axis. They need to be small negative values, and then they need to be high negative values. So low negative values would be small negative numbers, down to high negative values. So it looks very, very similar to the original function right there, because this also had low negative values and high negative values. But these are low slopes and high slopes is what I'm now drawing. A low slope has a small number close to 0. A high slope has a larger and larger value. Okay. For the next segment, we're looking at increasing functions. And so our increasing functions right now are going to have f prime be positive because we're increasing. But first, we have high values. And then they get smaller and smaller and smaller until they have a horizontal tangent. That's going to be where the derivative is 0. So the derivative will actually be 0 as 0. So I'm going to go through the ordered pair 0, 0. We're going to have high values, high positive values, getting smaller and smaller and smaller until they hit 0. Okay. I could have flattened that out. Let me just draw one more graph up there. I could have flattened that out a little bit more and made those closer and closer to 0 right there, because around -1 is really where they started to get super, super low. So the purple graph is probably a little more accurate because I see that very, very flat region starts around -1. It's not that very, very flat region, very, very close to 0 value starting there. Okay. Now, on the other side of x equals 0, I have the opposite happening. Again, they're very, very low values going to very, very high values, and they're decreasing. So f prime is negative, and we're going low to high. So we are very low, again, for a little while, maybe until a half. And then we go very high, remembering that any value that is not in the domain of the original function is also not in the domain of the derivative. So I must have an asymptote at 1 here as well. Okay. For the final section, we have something that is decreasing, so the derivative is negative, and these are very steep, so they're high negative values to very low. So high negative values down to very low negative values. So altogether, this is the graph, or a possible graph, for